Here's a problem from 1989 under the category functions. If f of n plus 1 is equal to 2 times f of n plus 1 all over 2, and f of 1 equals 2, find f of 101. So let's rewrite the formula for f of n plus 1. And that's f of n plus 1/2. And now we can see how the function works by making a table. So let's start at x equals 1, which we already know f of 1 is 2. But let's say we want to find f of 2. So f of 1 plus 1, where we look at the case where n equals 1, is equal to f of 1 plus 1/2. So f of 2 equals, we already know this is 2 plus 1/2. And you can see that makes sense because this is some term, and this is the term coming after it, and it's just 1/2 plus the term that came before it. So you can see that we just keep adding 1/2 until we get to 101. So to find the function value at 101, we have to see how many jumps there are to get from 1 to 101. And there's 100 so-called increments. So you have to add 1/2 to f of x 100 times. So you start at 2. Oh, wrong thing. You start at 2 and you add 1/2 100 times. And that gives you 52. So f of x is 52 when x is 101. And that's what we were trying to find. I chose this problem because it's important to know how to deal with this type of function, and the formal name for this is a recursive function. And like a general description is where the next term is defined by some other terms in this sequence. In this case, it was just adding 1/2 to a term that came before it, but they can be more complicated. A good example of the recursive function is the Fibonacci sequence. So it starts at 1, 1, 2, 3, 5, 8, and it goes on. And you can see that every term is the sum of the two previous terms. So we start with 1 and 1, which we just are given. And then 2 is equals 2. And then 1 plus 2 equals 3. And 2 plus 3 equals 5. 3 plus 5 equals 8, and so on. So this is a recursive function where f of n plus 2 equals f of n plus 1 plus f of n. So the term that's 2 spots ahead, this term, is the sum of these two terms. And f of 1 equals 1 and f of 2 equals 2. It equals 1, I meant. And then you can see that f of 3 is equal to the sum of the two previous ones, and you get 2. F of 4 is the sum of the two previous ones, and you get 3, and so on. And that's the Fibonacci sequence. And this is interesting because it's found in nature a lot. So now that I'm done getting sidetracked with the Fibonacci sequence, yeah, that's how to deal with recursive functions.